Okay, so this video is just a bit of a refresher of Pythagoras' theorem. So you need to remember that Pythagoras' theorem only relates to right angle triangles, only. It's pretty simple. We can use it to find any side of a right angle triangle as long as we have the other two sides. So our rule is c squared equals a squared plus b squared. Remembering that that basically means if I square this number, so that comes out this way, and I square this number, comes out that way, and I square this number, comes out this way, the hypotenuse, which is always c, will be equal. That big square will be the same as this square and this square. So if I place those two squares on here, they would be equal. So that's the basis of Pythagoras' theorem. You should remember this from grade 8. Okay, and so basically for any of these, we just sub in. So for this one, I just need to make sure that I put them in the right spot. So, as I said, C is always the hypotenuse. A and B are the other two sides. It doesn't matter which. So 15 squared, my hypotenuse. I'm just going to make the first one A, 9 squared, and then I'll leave that as B squared. So then when I look at 15 squared, I get 225. Then I need to square 9 and I get 81, and my b squared stays the same. Now what I want to do is I want to get b squared on its own. So in order to do that, if I'm adding 81 to b squared, I need to subtract 81. And so that's basically, I'm just going to swap b squared over to this side. Actually, sorry. We should actually have made this, after we did the b, we should have subbed this in because they did give us a value for b. They did. They called it k. And because they called it k, I should actually have this as k, a little k. So I'm just going to put it on the other side, k squared, and just put these on this one. So just a straight swap. So 225, and because I'm adding 81 here, I'm going to take 81. Oh, and because I've written it there, I don't need to actually do that. So I get 144. 225 minus 81 is 144. So this is the part where people often stop and don't go any further. You only know what k squared is. You only know what this whole square is. You want to know what k is. So to find k, it's terrible k, I actually need to do the opposite of squaring. So I need to find the square root. So I'm going to square root 144 is what I'm doing, yeah? So I put that into my calculator and I get 12. Therefore, the missing side is 12 centimeters. Okay, so fairly straightforward, fairly simple. I want you to do this one. So just pause the video and have a go at that, and then you can keep going and I'll go through the answer. Okay, so c squared, a squared plus b squared. Definitely making sure that you are writing your rule because that's your K1. Okay, so my hypotenuse is 30. I do have that one. And I'll make 18A. And this one is also a K. So then I just square. So I get 900, 30 times 30. 18 times 18 is 324. Just trying to read my writing there. K squared the same. I'm adding 324, so if I take 324 from both sides, I'm left with k squared. So I can actually, you know, take 324. So I can leave that here, I can take that away from here, that leaves k squared, and that's 900 minus 324, which gives me 576. So now I can actually swap them around, which is all I did up there. And say, actually, sorry, to get rid of that squared, I'm going to take the square root of both sides. So that will leave me with k, because k times k is k squared. And the square root of 576 is 24. Therefore, My missing side is 24 centimetres. Okay, so remembering our sub in here is K2. So are these ones. These are my communication over this side. This is where I show K3, where I've actually calculated, and my ending up with M3, my informed decision actually relating back. Again, it's only a straightforward fluency question, so you often won't have M3 there, but it is always, always good practice to write a therefore statement at the end of every question. Okay, now just going to wipe this off and we'll do some word problems. Okay, word problems with Pythagoras, which is really what Maths A is all about, contextualizing the problem. Basically, you need to be able to read a problem and model it by drawing a diagram and then choosing the correct formula or rule or problem-solving technique in order to solve the problem. While I have told you that we're looking at Pythagoras' theorem, you do need to make sure that when you draw out your triangle or when you draw your diagram, that it is actually a right angled triangle. If it's not a right angled triangle, you can't use Pythagoras' theorem and you'll have to find another method to solve the problem. Okay, so a boat sails 3 nautical miles north, then sails 2.2 nautical miles east. How far is the boat from its starting point? Let's draw a diagram. Here is its starting point. So from the start, it sails 3 nautical miles north. 3 nautical miles north. Then it turns due east. So because we're using compass points, I know that that is going to be a right angle. This will be 2.2 nautical miles. How far is the boat from its starting point? So this is its finishing point. This is where the boat is now, and that is the direct distance back to the start. So I look at that and I say to myself, that's a right angled triangle. I need to find the hypotenuse, and I've been given 2 other sides. I can use Pythagoras for that. C squared is equal to A squared plus B squared. C squared is going to be X. That's what I'm finding. A squared can be 3 and B squared can be 2.2. 3 squared is 9. 3 3s are 9. 2.2 squared is 1.44. If I add them together, I get 10.44. Now, to find x, because this is x squared, I'm going to find the square root. That's the opposite. 10.44. Square root of 10.44 is 3.231 nautical miles. Therefore, the direct distance from start to finish is 3.231 nautical miles. So what's really important to note here is I get M1. That's my problem solving. And over here I get K1, probably M1 as well. That's how I'm actually modeling it out. That is, and I'm using my diagram to show how I'm going to solve this problem. I would get C1, I would get C2 for presentation, I'd get C3 for translating information from words to a diagram. Over here I'd get K2 to sub in all the way down. I'd get K3 for calculating, and I'd get M3 for an informed decision, making sure that I'm actually putting it back into the context of the real life problem. Okay, this one. Our last one is a little more involved. A fire is on the 12th floor. A child needs to be rescued from a window that is 20 metres above ground level. If the rescue ladder can be placed no closer than 6 metres from the foot of the building, what is the minimum length ladder needed to make the rescue? Give your answer correct to the nearest metre. Okay, so straight off I go, a fire is on the 12th floor. Doesn't really help me with drawing the diagram. So what I know is there's a building. So that's my building and that's my ground, and they will come at a right angle. That's as much as I know so far. A child needs to be rescued from a window that is 20 metres above ground level. Well, I'm making this the bottom of the window, so this is going to be 20 metres. If the rescue ladder can be placed no closer than 6 metres from the foot of the building. So my ladder needs to come out like this, and this distance needs to be no closer than 6 meters. That is the minimum distance. So minimum length ladder needed to make the rescue. I need to place it at minimum distance then in order to get the shortest ladder possible. This is the distance that I'm trying to find, the length of the ladder. So I can see from my drawing, I have a right angled triangle, I have 2 sides, and I need to find another. I know I can use Pythagoras for that. So I am actually finding the hypotenuse here again. I'm going to put 20 and 6. 20 by 20 is 400. 6 sixes are 36. So I get 436 for x squared. To find x, I need to do the opposite of x squared, or the inverse. I'm going to find the square root of 436. And what I find is, that is 20.8. Now, the question tells me, give your answer correct to the nearest meter. Now I'm going to round that to 21 meters. Now, what I need to point out is, looking at reasonableness of a solution and the information given in this question. Now, if this was 20.4, so 20.8, that 8 tells us it's 5 or above, we round up, so that's going to round to 21. Normally, if I had 20.4 though, that 4, if it's less than 5, we normally keep the same, so I'd normally just round down to 20. However, in this situation, I want the minimum length ladder needed to make the rescue. Now, if I rounded this, if this was my answer, and I rounded it down to 20, I would be 0.4 of a meter short of the bottom of the window. Now, if my ladder actually needed to rest on that, then on the edge of the window, in order for it to be used, then it would mean that I would have to bring the foot of the ladder in, and it would no longer be safely used at the correct angle. So, always in this situation, round up, because I'm looking at a minimum length needed. Anything over a whole meter amount is that little bit more there that if I just rounded it down and took that off, I wouldn't actually have the length ladder that I needed. So always rounding up, and therefore minimum length ladder needed for the rescue is 21 meters. And I actually could put needed for the safe rescue, because really that's part of what this problem is about. Okay, so hopefully you have a better understanding of how to break down a work question, draw a diagram using the information from that problem, and then calculating it, in this instance using Pythagoras. It is important to note though, in your exam you will have a variety of formulas and problem solving strategies to choose from. You need to be able to identify the correct one. In this instance, to use Pythagoras, you need a right angled triangle. You need to have been given 2 sides of that triangle and be needing to find a 3rd side. So that's the information you need, information you can find, and it must be a right angled triangle.